There we go. I apologize, Sarah. I forgot to start the recording, so I started halfway. Okay, just to recap, today we're going to talk about the speed of light and the speed of sound. Okay? All right. Let's move on to the next. Oh, yes, somebody had a question. Yes.
In my class, we were talking about light and sound. And
Oh, good. Good.
Yeah.
This is really relevant. This is going to be kind of cool. It's going to fit what you're already learning. I'm glad. So we know light travels faster than sound because we see the lightning first. That one we know. We just don't know how much faster it is, right? Okay, so let's find out how much faster it is by watching a little short bit in this video. Okay, give me a thumbs up if you can hear the video when it plays, okay?
When light and sound are being perceived together,
okay,
this discrepancy in speeds can deceive you.
We can't hear it anymore. We can't hear you.
Oh, I'm not talking. I paused myself so that we could hear the video.
I couldn't hear after a second.
Oh, it stopped playing after a second. Let me try that again. Let's try this one more time, okay? Let's see. Okay, I think I'll keep myself on without muting, and we'll see if the video works this time. Give me a thumbs up if you can hear it.
Together, this discrepancy in speeds
Okay.
can deceive you. An example of this is when you're trying to locate a plane in the sky from its sound, only to realize it's far ahead of where it sounds like it is. Let's try to visualize and compare the speed of sound and light to understand how much quicker the speed of light is than sound. To visualize the speed of sound, we'll need something considerably large, the Golden Gate Bridge in San Francisco, California. The span between both towers is 1,280 meters. This is a great distance to see how quickly sound can get from one side to the other. I'll use a bullet to represent the speed of sound, as some 9mm bullets travel the speed of sound, 343 meters every second. If I shot a bullet from one tower to the other, it would reach the second tower in 3.7 seconds. This is what the speed of sound looks like bouncing from tower to tower in real time. The speed of light, on the other hand, is a lot quicker. To visualize the speed of light, we will need an object so large that we will need the whole planet. Planet Earth. The Earth's circumference is 40,000 nothing for the speed of light, as it is able to circle the Earth 7.5 times every second.
Okay, so we know the speed of light is much, much, much faster than the speed of sound, right? Okay, oh, hang on, my shared screen turned off. Give me a moment here. There we go. I got it back on. Apologize for that. Yeah, so we know it's much faster than the speed of sound. We know the speed of sound is pretty fast, though. It's almost the speed of the bullet, which is like 343, what was it? 343 miles per second or kilometers per second, I think is what it said. Yeah. Here we go. Can you think of anything that travels at the speed of sound or that is faster than the speed of sound? You sure? I think you know at least one thing. We talked about it earlier. It's faster than the speed of sound.
A bullet?
A bullet travels at the same speed as the speed of sound, but what did we mention when I said, hey, which one is faster, light or sound?
An airplane? I don't really remember.
Lightning. Lightning is faster than sound, right? Lightning is faster than sound. Sometimes, if you think about it, because lightning travels faster than sound, what does thunder sound like?
Like a mini explosion to me.
Yeah. It has a boom.
Yeah.
Right? So when something travels faster than sound, the interesting thing is when it travels faster than sound, it makes a boom called a sonic boom. It's a real thing where it makes this loud noise that sounds like an explosion. That is exactly what thunder is. The light is traveling so fast, we see it and then hear the sonic boom. So let's see. We're so lucky. We live in California where there's SpaceX and they shoot rockets off to space ever so often. This video is a video of a rocket landing. It's called SpaceX. And when it lands, it's moving really fast. It's far in the distance. It'll be like a tiny white dot in the distance, and you'll see the people watching it. So when it's landing, do you think it's moving really fast or really slowly?
Really fast.
Okay, it's moving really fast. Okay. So do you think it's moving slower than the speed of sound or faster than the speed of sound?
Faster than the speed of sound.
Okay, faster than the speed of sound. So our guess is that the rocket is going to land really, really fast and it's going to be going faster than the speed of sound. So what do you think will happen?
Can you repeat it, please?
Oh, okay. We know, well, we're guessing here the rocket is going to be going really fast. We're also hypothesizing that it's going to be faster than the speed of sound. Since we're making that assumption, what do you think will happen? Yes.
I think like a ring of wind, since it's going so fast, will go around it since it's going really fast.
Okay, that's one idea.
I
Any
al-
other ideas?
I've also seen like cartoons. It like gets like a bit of like on fire, the part that's actually heading down.
Okay, okay. Anything else? Do you want to guess? No? Shall we just watch it then? Okay, let's see. It's just a short clip, and like I told you, the rocket's like really far in the distance. It looked like a white dot, so keep an eye out for a white dot, okay? There we go. Let's see the white moving dot. That's the rocket landing. What was that? Yes.
It launched. The rocket launched.
No, the rocket landed.
Yeah, yeah. I mean that.
Like lightning, it was going faster than sound. So yeah.
So the sound came after it landed, right? That's exactly what happened. Just like lightning, we could see it. So you can see it because the light is bouncing off of it. So we can see it, it landed, but it was just going so fast. By the time the sound caught up, it was a boom. That was pretty scary for everybody who was there. And that's called a sonic boom. Isn't that cool? And that's real. That's not a cartoon. That's how it really happens when rockets land. That's pretty fun. And so that is exactly how lightning works too. Lightning shoots out so fast, we see it so fast, and later we hear the sound. So here's an interesting note. The speed of sound is actually, oh, I should have written down the slide, my bad. The speed of sound is actually 343 meters per second, which means actually it can do 1 mile in about 4.5 seconds. That's how fast sound can travel. By 1 mile in about 4.5 seconds. That's pretty fast. So I don't know if you guys ever like to look at fighter jets or anything like that, or maybe in cartoons you've seen it. You might have heard this word called Mach. Yes, you've heard of it?
Me and Wesley, my dad picked us up from school once, and we went to the beach and we saw a fighter jet show.
Yeah, yeah, exactly. And when you were watching the show, did they ever say anything like, "Oh, traveling at Mach something something"? Did they say something like that?
Very fast.
Yes. So Mach is another word that they use to represent the speed of sound, which we know is really fast. The speed of sound is 343 meters a second, or something is going like 1 mile in 4.5 seconds. So when they say a plane is traveling at Mach 2, that means it's traveling at 2 times the speed of sound. Isn't that crazy? That's pretty crazy. To 2 times the speed of sound, that means it would do 1 mile in about like 2 seconds. You're like blink and boom, it's gone. So when you saw the fighter jet show, if you're watching a plane that had the speed of sound or faster, that was faster than the speed of sound, what you would have seen is you would have seen the plane fly by, and then later you would have heard a boom. Did you experience that at the fighter jet show? You did? Yeah, so you saw something traveling faster than the speed of sound. Awesome, that's pretty cool. I've only seen those in videos. All right. Well, we know sound is really fast because 1 mile in 4.5 seconds for sound is pretty fast. Let's switch gears a bit. Let's just make a guess here. How far do you think the Earth is from the sun? Okay, like I know it's like a big number. I don't need you. Oh, yes, go ahead.
I think it's about like 200,050 and like 200,990 or something.
990 what? Miles?
Yeah,
Yeah,
away.
that's pretty far. Okay, that's your guess. Anybody else want to give a different guess?
You have to guess which how
Like 500,000 miles.
Okay, okay, that's pretty far too. Okay, let's find out. I can tell you, but I think it might be more fun to see it in a video. Are you ready? Okay. I'm gonna have to rewind this video a bit, so forgive me for that. Start it
How
right here. Can you hear it?
If you ask how far away Earth orbits the sun, most people give an answer like this.
Right here, I guess.
And it's kind of understandable,
About right there.
because every picture of the solar system ever looks like these, including my own report on the solar system from the 4th grade. So this is the true scale of the solar system, starting with our size 5 soccer ball sun, which puts Mercury at the 10-yard line as a mere fleck of pepper. Next is Venus at the 19-yard line, and it's about the head of a pin. Next up is my favorite planet, Earth, orbited by our grain of salt moon. So if you retain nothing else from this video, just remember that Earth is the size of a head of a pin, and it's at the 26-yard line. And as the final rocky planet, we have Mars at the 40-yard line, also a fleck of pepper. And now we start to see bigger gaps. At more than a football field away from our sun, we have Jupiter, which is the scaled size of a grape. And after a little bit of exercise, we come to Saturn, which is a slightly smaller grape and 2.5 football fields away from our soccer ball sun. Next up is the 7th planet Uranus, which is the size of a pea, and its orbit is an average of 5 football fields away from our sun. And finally we come to Neptune, which is also the size of a pea and orbits around our sun the size of a soccer ball, nearly 8 football fields away. Now, this view should help you appreciate the difficulty in accurately representing both the size and distance between the planets in a single image. Okay, so before we get to the new 9th planet, let's recap. So we've got a pepper flake at the 10-yard line for Mercury, and then a pinhead at the 18-yard line for Venus, and then another pinhead for Earth at the 26-yard line, and then a pepper flake for Mars at about the 40. And then of course the asteroid belt, and then we make it to Jupiter, which is a grape at about 135 yards. Then we cross the street to get to Saturn, which is a grape that orbits at about 2.5 football fields around our soccer ball sun. Then we double our distance from the sun to get to the 7th planet, which is a pea at 5 football fields away. And finally, at nearly 8 football fields away from our sun, we have another pea, which is Neptune. And now we've laid the framework for understanding just how far away planet.
Okay, what'd you think? Did you realize how far away the sun was from the Earth before?
Yes.
You knew that? That didn't surprise you, you already knew how far away it was?
Well, it did surprise me. Yes, I did not know this.
Yeah.
It's actually like, to be more specific, the distance from the Earth to the sun is about 93 million miles away. 93 million. Yes.
2 questions.
Yes.
I think that the first one was gonna be, is that the Sarah we know, and it actually is. So I wanted to tell you, I think it's about no. Are you gonna let Guy have a turn? Guy and Jasper have a turn doing the guessing thing?
No, it's okay. Can you tilt your camera down a bit so I can see your faces more? I can only see your eyes actually, so it's kind of hard to see. There we go. Talk to me.
Are we late?
Yeah, we start at 6:30, but don't worry. We've still got some information to go. Welcome. Thank you for coming. So we were just discussing how far the Earth is from the sun, and we watched a quick video and it talked about how the Earth is super far away from the sun. It's like 93 million miles from it. It's pretty far, okay? So I just want to go, we know that sound has a speed. We know that light has a speed. Now, how long do you think it takes for us to see the light from the moon? So if we're on Earth, how long do you think the light takes from the moon to get to us? How long? Yes.
8 minutes.
You think 8 minutes from the moon to the Earth?
I think I've learned that before.
Wesley.
Okay. And then anybody else had their hands up? Yes.
1 month.
1 month from the moon to the Earth. Okay, Guy and Jasper.
No.
Hannah, what did you say?
Like 10 seconds.
10 seconds. Okay. Okay.
Okay.
Okay, then I have a different question. We're talking about the Earth from the moon, right? How long do you think light takes to travel from the sun to the Earth? Yes.
I think about 4.5 seconds.
4.5 seconds.
I think like 3 to 5 minutes.
Okay, Guy and Jasper.
I think it's like 900 milliseconds.
Okay. All right, well, let's watch a quick bit to see who's right, okay? Okay, give me a thumbs up if you can hear the video when it plays.
Let's zoom out to see the speed of light traveling between the Earth and the Moon. The Moon is 384,400 kilometers away. It takes the speed of light only 1.28 seconds. If a light source was heading to the sun being 147,450,000 kilometers away, it would take light 8 minutes and 20 seconds one way.
So I think, Will, you were trying to say earlier that it took like 8 minutes to travel from the moon to the earth, but
Yeah, it was me.
it was from the sun to the earth.
Yeah.
So from the moon to the earth is about 1.28 seconds, but from the sun to the earth, it's 8 minutes, 20 seconds to travel one way. Isn't that crazy? That's how far away the sun is from the earth, that it takes 8 whole minutes to get to us. Crazy, huh? Now, I don't know if any of you were aware, you guys were probably in school on Monday, but there was a solar eclipse. Yes.
We got to bring solar eclipse glasses to school. It
Oh,
was
cool.
Me and Jasper too. We go to
Yeah.
the same school as Wes and Will.
Okay, so did you guys look at it? What'd you see?
A solar eclipse. It looked like a giant orange in the sky, and like it looked like something took a giant bite out of it.
Yeah. Cool. Did they talk about it at school too, since you got to watch it while you were in school?
No.
No, they didn't talk about it?
Well, yeah. Well, kind of not, and yeah.
Not completely, maybe. Okay, we'll talk about it a bit here. So you saw a little bit of it. So question, was it completely dark?
No.
No. So it wasn't what they call a total eclipse over here. It was a partial eclipse. Yes, you have your hand up? Yes. What's up?
I know that in Texas, it's actually pretty dark.
Yeah. Yeah, I was about to say that. Was that what you were about to say too, Guy?
No, I was just gonna say that there's gonna be a solar eclipse for like we live in 2045.
Yeah. So a total solar eclipse is when it gets completely dark, but that didn't happen right here in California. It happened in Texas and a few other places in the US. We only got what's called a partial eclipse. So without the eclipse glasses, you wouldn't really have seen anything. It would have just looked like a normal day outside. You wouldn't have noticed that it got darker. But because you had the eclipse glasses, you were able to see the bite out of the sun, like you were saying. You could see that. So did any of you get to see the eclipse on video? No?
No.
No. Oh, well, I got a treat because I found a great video of the total solar eclipse that happened last Monday. It was last Monday, a week ago. So we could watch it together. Well, before we do that, let's watch a quick video explaining what happens, because I think you said they didn't really discuss it much in school. So what do you think happened since they didn't discuss it in school? Do you have an idea?
The sun like covers this like the moon goes around the earth, like when like the moon covers the sunlight going on to the earth, even though it's smaller, it just looks like the same size, since they're like the sun's huge and like the moon's closer and stuff.
Okay, that's a good theory. Yes, Will.
Also, pretty much all of us learned that.
I saw news in Texas, and it actually was very dark.
Yeah,
Yeah, that's
very dark. So it's very similar to what Guy said. We know the moon is going around the earth. We know the earth is going around the sun. And we know at some point it lines up such that the moon is blocking our view of the sun. And so it seems darker. The sun is still there, it just happens to be behind the moon and get blocked. But this video explains it really quickly. And after that, we're going to watch a video of the real total solar eclipse. This was, the video I think was recorded in Cleveland, Ohio, but they also experienced the same total solar eclipse as Texas. They just experienced it later in the day.
A solar eclipse happens when the moon's shadow falls somewhere on the surface of Earth, and a lunar eclipse is the opposite, when the Earth's shadow falls on the moon. The two sections of the shadow, the dark umbra and the partially shaded penumbra, their placement determines which type of eclipse we can see from Earth. But not all eclipses are made equal. The most spectacular, the one for your bucket list, is a total eclipse of the sun. A total solar eclipse begins as a partial eclipse. You'll notice trees projecting the crescent sun and shadows becoming sharper than normal. The landscape darkens to a bluish gray, and you'll start to feel the temperature drop. From the west, the moon's shadow rushes towards you like a silent storm. Look up, and you'll see the last sliver of the sun sparkling like a diamond ring before it's broken into a string of beads by the moon's rough terrain. Now you can see the pearly glow of the sun's corona and the pink and red light from the hydrogen gas of the chromosphere. Together, these make up the sun's outer atmosphere, and a total solar eclipse is the only occasion you have to lay eyes on it. This is totality, and if you get a chance...
Okay, so to give you a short explanation as to what the solar eclipse was, which is exactly what Guy was saying earlier, what I said too. So here's an interesting thing. I think they mentioned in the video, the sun, can you see this? Is it visible? There we go. Looks like a sun. The sun is about 4 times as wide as the moon. I know these look like, this looks so tiny compared to this, but the moon is just 4 times as wide as the sun. So it's made a sample for you. 1, 2, 3, 4. It's 4 times as wide. And so what happens is, I don't think you'll be able to see it because I'm against the wall here. So I'm looking at the sun. The moon will cover it at some point. And the distance from me to the moon and from me to the sun is 4 times. Does that make sense? That is exactly what happens in an eclipse. So to look at a real eclipse,
A solar eclipse happens when the moon's shadow falls...
Here we go. So the solar eclipse that happened on Monday last week. Let's do this. There we go. Got a little snippet of it.
And then Mentor Civic Amphitheater again, the field starting to fill.
And
and
getting
everybody
darker
looking up
outside
at the
because the sun is
sky
getting
for
covered
their
a bit more.
opportunity to see
You can
today's
see the
solar
corner
eclipse.
of the solar eclipse right there in the picture.
This
I'm
is
only
us back
checking
here
the
in
number.
Cleveland. Everybody looking up at the sky. We have 30 seconds. 30 seconds until totality.
So it looks like
here
it's
in
like
Cleveland,
nighttime.
Ohio.
Looks like the
Oh
sun
my
is
God,
setting,
I
but
have
it's not setting. It's
goosebumps
the solar
everywhere.
eclipse is
Everybody's
actually
starting
happening.
to cheer. I might cry. I kind of feel like crying. This is so cool to see. It's getting so dark so fast.
So the sun's getting covered by the moon.
And look at the crescent slowly disappearing. Crowds
And
cheering.
once it gets
Cell
covered, you
phones
get to
up,
see more of the
cameras up.
outside
5,
glow of the sun.
4, 3, 2, 1, and totality. Totality, everyone.
And that's a total solar eclipse. That's what it would look like. So if you were standing outside while this was taking place, you would literally be standing in what seemed like the black of night.
I was so nervous.
Wow, I know, I wasn't sure because we had some high clouds, but oh my goodness, you can see that corona extending out. Oh wow.
Isn't that cool?
The clouds were really bothering me and really scaring me. You get very cloudy.
So the
here
only reason
in
you can
last
see the
hour and
glow
a
of the
half,
sun
but we
during a
have
total
great
solar
view
eclipse is
here
because it's
in
as if the
Cleveland,
sun is
Ohio.
blocked out
Yes.
and the light of the sun is turned off.
You can hear the
That way you
crowd.
can see the glow. Otherwise
Wow,
you can't. The
everybody's got their
sun is
phones
just so
out.
bright you
Oh
can't
my
see it.
gosh.
Wow. You know, I saw pictures of what the shape of the corona might look like from our NASA scientists, and it looks exactly like they predicted.
Oh my gosh. Oh, and you can see Jupiter and Venus.
So
Oh,
how
yeah, look
long
at
do you
that.
think
So
a
Jupiter's to the
total
upper
solar
left
eclipse
of
lasts, you
the
guys?
eclipse that we're watching, and just to the right of it is
Yes.
Venus.
Yes.
What do you think?
Oh, and I see some of those pink protuberances we've been talking about all day.
Wow.
Beautiful.
Oh, like 10
And again,
minutes.
all around us, you see
10 minutes? Is that what you
but
said?
just at
Yeah,
the
it's
top
like
where
it's
we
like a
are.
360 sunset.
Actually,
Exactly.
usually
Yes,
they
and
last
Indianapolis
about
had
3 to
described
4
that as well.
minutes. So depending where you were, you would see it for like 3.5 to 4.5 minutes.
We have totality here.
You'll have
for
the
3 minutes
complete
and 50
darkness for
seconds.
3.5 to
And it's
4.5
such a
minutes, and then it'll
luxurious
get
amount
bright
of
again,
time. I saw
just
the
like sunrise.
2017. I think we only had about 2 minutes. So.
Yes, you
Why
had a
is
question?
that? Why does the length of totality
What's up?
differ?
Oh yeah, well, because sometimes the moon is a little closer, a little further
I'm
away. Its orbit's
wondering why
elliptical, and
there's
so when
no
it's further
clouds
away,
at
it looks
night.
smaller in the sky. But when it's closer, it looks bigger, and so.
You're wondering why what, honey?
There's no clouds at nighttime.
Oh, well, they just happened to not have clouds when they shot the solar eclipse over here. Certain places it was pretty cloudy that they couldn't really see it well. So it just happened to be that this day they didn't have any clouds. Did you guys have any other questions about the eclipse? No? Okay. Well, so we know the eclipse is what? The moon's shadow on the earth, right? Yes? So this is a real image from the International Space Station. So they were above the earth while the solar eclipse was taking place, and they can actually see the shadow of the moon on the earth, and this is what they saw. You see that? That is the shadow of the moon on the earth, and the space station was looking at it like, whoa, they can see the eclipse actually happening from the outside. So that was their view from the space station. It's pretty neat. Did you know there's actually a way to see what the space station is viewing at any point? There's actually YouTube on it. And so you can see what the space station is viewing at any point in time. So at this point, it tells you they're flying over this part of the world. This is what they see. And since the space station goes around the Earth, if they're not on the same side of the Earth that's facing the sun, the video feed will be dark. Isn't that interesting? So if you were to look in the morning and check out this channel, you'll see it's a dark feed. And then at that time, all you'd be able to see on the Earth is any lightning bolts from the sky. It's pretty nifty. Just for fun, I thought I'd include that. You guys can go look at that anytime. Well, here's a fun experiment you can do at home. You can sort of make your own solar eclipse. You have two choices. You can just draw a circle on a sheet of paper if you want, or you can just get objects that are circles, like this is a lid of a Tupperware, and this is a little cup that's another circle. So you can try it. To make it easier, you can get one lid that's twice as big as another container, and you can hold it up to understand how the eclipse works. Like, for example, just like I did earlier. If I hold my hand out, can you see me holding the lid? Yeah, I'm holding my hand out. If I look through the cup matches the size of my bigger lid exactly halfway, because this is half the size of this. But if this was a quarter the size of this will match up a quarter of the way. That's exactly how it works for solar eclipse. So you can find lids and experiment this at home. When you do this experiment, you have to understand that you are the Earth, this is the moon, and this is the sun. And when it lines up, that's what's happening during eclipse. Okay? Do that anytime. But I do have a question for you guys, since you guys are here, Guy and Jasper. Did you guys have a chance to do the experiment from last time with the water cups?
No. Well, yeah, but we didn't really do it. I kind of forgot about it.
What'd you say? I couldn't hear you.
I forgot about this experiment.
Oh, so just stayed in the freezer.
Yeah, so
Okay.
Yeah.
Yeah, it's worth trying it again because you're gonna find out some really interesting results. and you'll find out about whether sugar solution, water, or salt solution freezes faster than each other. That's a fun experiment to do. You just got to check it like every half an hour, and then you'll find out. It's a fun one. But anyways, we got to go soon. Thank you all for coming. Do you guys have any questions? You
This
do?
is like
What's up?
something I gotta say, like, is it convenient that me and Jasper and Wesley and Will are the only ones that joined this meeting?
No, that's not true. There's been other people before.
What?
Just happens the last couple months. You guys were free.
Wow.
You never know. You got a question there?
What are we doing next time?
You know, I have a list that I tend to go through and pick a different topic from my list. Let me go check it out. By the way, next meeting will be May 20th. But let me go find my list of ideas. Let's see, we just did speed. Well, the next time I was going to talk about, I haven't done an art one in a while, but I was going to see maybe talking about electric cars. Thought that might be fun. Does that sound interesting? Yeah? Yes? No?
Yes.
Okay. That was sort of my next idea. We could do that. I usually tend to think of it the week before. But thank you for showing up, you guys. We're going to say bye. I appreciate you. Thank you for coming.
Bye.
See you next time on May 20th, okay?
Bye. Bye.
Bye-bye.
Bye, Jasper. Bye, guys. Say bye to Roy from me.
Bye-bye.
Bye.
Bye.